Good morning, student. Today we will start the new chapter of physics, that is mechanics. And this mechanics chapter which is very important because this chapter which is linked to your second year chapter also. So what is mechanics? In mechanics we deals with or we will study here the nature of force or type of force and type of motion, and the relationship is known as mechanics. Means that is here we will study here force, motion and their relationship. Relationship is known as mechanics. And this mechanics which is divided by three parts. Basically it is three type of. So first one, that is static, and second one, that is kinematics, and third one dynamics. Clear? So mechanics which is divided by three parts: static, kinetic and dynamics. So what is the meaning of static? Static means rest, means when here we will study the properties of an object which is at rest. You can say the property or study of body, study of an object which is at rest or equilibrium condition. Equilibrium under action of different forces. Clear? Suppose a body which is rest condition on the surface, you can say the body is under the static condition. Or if net force acting on the body, then if body which is the rest condition also, means net force acting on the body will be zero, that condition is known as equilibrium condition. Means suppose if we apply here 8 Newton force and this direction also 8 Newton force, then net force acting on the body which is equal to 0, and that condition is known as equilibrium condition, and body which is the rest condition. Clear? This is known as static condition. So next come to kinematic. Kinematic means here we deals with the study of an object, and we deals with the study of an object in motion condition. So here study motion of an object without its cause. Means we have to study here only effect. मैं काइनेमेटिक्स रे कौन पढ़िया गोटा बॉडी मोशन कंडीशन रे अछि. ठीक अछि भाई, मोशन कंडीशन रे अछि. कौन पाई मोशन कंडीशन रे अछि? व्हाट आर द कॉजेस ऑफ द मोशन? विदाउट कॉज वी विल डिस्कस हियर मोशन ऑफ द बॉडी और मोशन ऑफ एन ऑब्जेक्ट. कॉज हमर किछि दरकार नाही, आमे जानिया दरकार खाली मोशन कौन पाई, सॉरी मोशन होउछि. ठीक अछि, किंतु कौन पाई मोशन होउछि आमे काइनेमेटिक्स रे ता डिस्कस करिबा नाही. क्लियर? Next come to dynamics. So what is dynamics means? We will study here motion of an object with cause of motion. With cause of motion. Motion कौन पाई होउची, तार कारण कौन आमे डायनामिक्स रे पढ़िबा. सपोज देयर इज ए बॉडी व्हिच इज मूविंग दिस पाथ, और यू कैन से ऑन द ग्राउंड, एंड हियर सपोज इट पोजेस वेलोसिटी 2 मीटर पर सेकेंड दिस डायरेक्शन. तले ए पार्टिकल और बॉडी कौन पाई 2 मीटर पर सेकेंड रे जाउची, आमे कोडी पढ़िबा डायनामिक्स रे पढ़िबा. मींस मोशन विथ इट्स कॉज, मोशन सहित कॉज पढ़िबा. बट इन काइनेमेटिक्स वी डील्स विथ only motions of an object विदाउट नोइंग इट्स कज किसी दरकार ना कौन पाई मोशन हो ठीक अच्छे मोशन हो आम जाना दरकार बट डायनामिक्स आम डिटेल्स पढ़ा कज कौन आ मोशन कौन बट स्टैटिक कंडीशन रे बॉडी व्हिच इज इक्विलिब्रियम कंडीशन मीन्स इफ वी अप्लाई number of forces act on it but resultant effect or resultant force on the particle or body which is equal to 0, that condition is known as static condition. Clear? So we will start your chapter that is known as kinematics. Clear? Okay. So there is another important term related with kinematics. First we will discuss here what is rest. What is rest and what is motion? Clear? So suppose there is two-dimensional case or two-dimensional coordinate system, x-axis and this axis y. Suppose there is a point P, it is coordinate x comma y and its position vector, this is r vector. Clear? When time t equal to 0, then particle situated or particle on point P after 1 second means time t equal to 1 second, then particle also at this point P with a coordinate that is x comma y means 0 time बेले आम देखिले particle P point रे अछि 5 मिनट पर देखिले particle P point रे अछि 10 मिनट पर देखिले particle P point रे अछि घंटा पर देखिले particle P point रे अछि. That means the position of the particle does not change. Clear? X axis रे position change होउनी कि y axis रे position change होउनी means particle को condition रे अछि rest condition रे. If position of the particle does not change, position not change, and that condition is known as rest condition. Particle को हमें rest condition रे कहि परिबा. Clear? Next, what is the meaning of motion? Same two-dimensional motion. Suppose here when time t equal to 0, particle situated at point P with position vector suppose r1. After 1 second, particle moves from point P to point Q. Another one point is here, and its coordinate position vector r2 vector, and its coordinate suppose this is x1 y1 and here x2 y2. Clear? But in this case your position vector is not fixed here. The coordinate of the particle change means x axis and y axis change हे चली. That type of relation is known as motion condition means boita को condition रे अछि motion condition रे अछि. So here the position of the particle changes with respect to this origin. A origin अनुसार यार position कौन है चलजी change है चलजी. So that we can say the particle under motion condition. Clear? So these are two important points, rest and motion condition. In motion condition, position change with respect to we can say origin. Origin respect रे position change है चलजी, but origin respect रे position change हो नहीं. Clear? So next start, rest and motions are relative term. Rest and motion are relative term. So what is the meaning of rest and motions are relative term? Means there is not possible absolute rest and absolute motion. So first we will discuss here what is absolute rest and absolute motion. Absolute motion means गोटे बॉडी सबुदिन पाई रेस्ट अच्छी कि और एमती किसी बॉडी अच्छी और ऑब्जेक्ट अच्छी सबुदिन पाई मोशन कंडीशन अच्छी कि व्हिच इज नॉट पॉसिबल मीन्स एब्सोल्यूट रेस्ट or absolute motion is not possible. Why? Because if we suppose there is a object which is absolute rest ताले एब्सोल्यूट रेस्ट है पाई कोन दरकार फर्स्ट वी हैव टू फाइंड ए initial point and that point is known as origin. Suppose this is x axis here and here y axis, this is origin and its position that is 0 0. Then suppose there is a particle p which is comma x comma y with a position vector r vector, means x axis रो x distance रे अछि, y axis रो y distance रे अछि, means suppose we can say here 2 3 means x axis रो 2 meter distance रे अछि, y axis रो भी 3 meter distance रे अछि, तो position केते ला 2 3. But here this origin it not fixed. Why? जदि आम स्पेस रे भी तुम गोटे नियो, सपोज मो स्पेस रे गोटे ओरिजिन चूज कली, द टोटल सराउंडिंग केस रे टोटल आमर यूनिवर्स रेस्ट कंडीशन अछि कि, टोटल अर्थ रेस्ट कंडीशन अछि कि, कहीं भी रेस्ट कंडीशन रे नहीं. तो जदि टोटल अर्थ रेस्ट कंडीशन रे नहीं, टोटल यूनिवर्स रेस्ट कंडीशन रे नहीं, ताले ए ओरिजिन पॉइंट ता फिक्स हैला कि बर्तमान ए ओरिजिन पॉइंट फिक्स अछि कि फिक्स नहीं, टोटल यूनिवर्स रोटेशन हो चलछि. यदि यूनिवर्स रोटेशन हैला सपोज t इक्वल टू 0 टाइम रे ये थिला कोऑर्डिनेट, ये थिला ओरिजिन, देन आफ्टर सर्टेन इंटरवल ऑफ टाइम ड्यू टू रोटेशन ऑफ द यूनिवर्स, सपोज टाइम t इक्वल टू 1 सेकंड, आई एम सेइंग टाइम t इक्वल टू 1 सेकंड, देन द ओरिजिन इज नॉट दिस पॉइंट, ये ओरिजिन भी चेंज हेथिबो आउ को पॉइंट को, बुझिला. ताले पार्टिकल सही पॉइंट रे अछि, ताले वर्तमान ए पॉइंट रे हम चूज करले, वर्तमान ए पळे आसिला पोजीशन वेक्टर ए पॉइंट, ताले पोजीशन वेक्टर चेंज हे गला. यदि टोटल यूनिवर्स टा फिक्स नाही, ताले गोटे पार्टिकल को हम केबे भी फिक्स करि परिबा नाही. क्लियर. सो एब्सोल्यूट रेस्ट मींस सब दिन पई कोनोसी ऑब्जेक्ट फुल रेस्ट हे परिबो नाही. दैट इज नॉट पॉसिबल फॉर एब्सोल्यूट रेस्ट ऑफ वन ऑब्जेक्ट. Similarly, absolute motion also not possible. सबुदिन पाई जने मोशन रे थिबो, सबुदिन पाई जने कांस्टेंट हे जाइथिबो, सेमिति के पॉसिबल नाही. ताले पॉसिबल कोन? पॉसिबल ओनली रेस्ट एंड मोशंस आर रिलेटिव टर्म. So we'll discuss here how rest and motions are relative term. Suppose there is a platform, train platform here, and your friend waiting to you this point, and suppose this is train which moving this direction, clear, moving towards this direction. Train ro compartment अछि, suppose this is compartment of a train and there is one seat and there is another one seat, clear. Suppose this is a person A or passenger, you can say this is passenger B and this is observer or this is C, clear. ये ट्रेन रो प्लेटफॉर्म अछि, ये ट्रेन लाइन ट्रेन आकु आकु चलछि, बुझा पड़ला ना. व्हेन ट्रेन अप्रोचिंग दिस डायरेक्शन means this is one compartment and there is two passenger A and B, but there is another friend waiting on the platform and whose name is suppose C, clear. Okay, एबे देखो when time t equal to 0, बर्तमान टाइम देखलो 0 सेकंड रे A B को कौन देखुछि, when train moving with constant some velocity v, तो ट्रेन v वेलोसिटी रे आकु आकु चले छी, ए से टाइम रे बी को कौन देखुछि, रेस्ट ना मोशन कंडीशन रे, रेस्ट कंडीशन रे. व्हाई? बिकॉज दे आर सिटिंग इन ए कंपार्टमेंट, गोटे कंपार्टमेंट रे सन बसछंदी, आ ए फ्रंट रे बी अछि, बी फ्रंट रे ए अछि. दैट्स व्हाई बी ऑब्जर्व ए ऑब्जर्व बी व्हिच इज रेस्ट कंडीशन. ताले ए वर्तमान बी को को कंडीशन रे देखुछि, दैट इज रेस्ट कंडीशन, क्लियर. बट when C observe B, say same time रे t equal to 0, or you can say suppose this is 10 a.m. तो टाइम 10टा है से टाइम रे ए देखला बी को रेस्ट कंडीशन रे अछि और ट्रेन भी वेलोसिटी आकु आकु मोशन रे अछि बट एबे सी से सेम टाइम रे एतले व्हेन ट्रेन क्रॉसिंग द प्लेटफॉर्म एट दैट टाइम सी ऑब्जर्व टू बी एंड व्हिच इज मूविंग कंडीशन एतले सी देखला बी को को कंडीशन रे अछि ना से मूविंग कंडीशन रे अछि मींस मोशन कंडीशन रे अछि व्हाई से सेम टाइम रे 10टा टाइम रे ए देखला बी को रेस्ट कंडीशन रे अछि दी जन जाक सेम कंपार्टमेंट रे बट एबे सी ऑब्जर्व कला बी को कंडीशन रे मोशन कंडीशन रे से सेम टाइम रे हाउ इज इट पॉसिबल दिस इज पॉसिबल ओनली व्हेन we chose frame of reference is important, compartment and platform is important because A and B which is sitting, they are sitting in a compartment which is this compartment which is moving with velocity v, means v velocity moving with b and v velocity moving with a, but here which standing on platform which is at rest condition तले a b को देखु रेस्ट कंडीशन रे b भी a को देखु रेस्ट कंडीशन रे बट जे प्लेटफॉर्म रे छिड़ा है से सेम टाइम रे त कोन देखु a को देखु मोशन कंडीशन रे b को भी देखु से टाइम रे मोशन कंडीशन रे क्लियर सो सेम टाइम इंटरवल रे a देखला b को रेस्ट b देखला a को रेस्ट सेम टाइम इंटरवल रे c देखला a को मोशन रे c देखला b को भी मोशन रे सो दैट the rest and motions are relative term, there is not possible absolute rest and absolute motion हाँ a कहि परियो b को सब दिन पाई रेस्ट अछि but c कहि परियो कि रेस्ट अछि no why because depends on frame of reference ताले ए कंपार्टमेंट रे जे माने अछंती there is another one frame of reference जे प्लेटफॉर्म रे छिड़ा है जी this is also another one frame of reference so that rest and motions are relative term so absolute rest and absolute motion is not possible only relative rest and motion possible clear that is the meaning of rest relative rest and relative motion possible absolute rest and absolute motion never possible clear okay so next we will start frame of reference and that frame of reference which is important so let's start frame of reference frame of reference so what is frame of reference frame of reference is a system where observer can observe the motions of its surrounding condition means frame of reference you can say it is a system where observer can see or observer can observe the motions of its surrounding motions of its surrounding so it is a system where observer can observe the motions of its surrounding suppose there is a lift and this is a lift and this lift which moving upward direction with some velocity v clear and there is one person standing inside the lift and another one person also standing inside the lift this is person number 1 and this is 2 clear and here this is ground level and here also one person standing this is person number 3 clear okay if we observe inside the lift, then and lift which moving with velocity v, if lift with moving velocity v, then 1 and 2 person also moving with same velocity. Why? Because they are inside the lift, and at a certain time when time t equal to 0, one observe 2 and 2 which is rest condition, and 2 observe 1 which is also rest condition. 1 जेतुले b को देखिबो से रेस्ट कंडीशन रे अछि, b जेतुले a को देखिबो रेस्ट कंडीशन. Why? Because they are moving with same velocity, but when at same time interval t equal to 0, मान करो एटा को 10 टा टाइम रे देखिला 10 am ये रेस्ट अछि से रेस्ट अछि, and at the same time 10 am when c observe 1 and 2, when c observe to 1 and 2, at that time they are moving with certain velocity which is upward direction. जले c third person first और second को देखिबो ए दि जन जाक upward direction रे ऊपर को ऊपर जाउछ. Clear? So this is known as frame of reference. This is one frame of reference, and this frame of reference is known as lift. Lift frame of reference. जेतुले थर्ड पर्सन नंबर 3 जेतुले ऑब्जर्व कला को कंडीशन अछि मोशन कंडीशन रे ये आउट ऑफ फ्रेम ऑफ रेफरेंस हे होला. ए कोन को ग्राउंड फ्रेम ऑफ रेफरेंस, ग्राउंड फ्रेम ऑफ रेफरेंस. ताले फ्रेम ऑफ रेफरेंस कोन? ताले फ्रेम ऑफ रेफरेंस गुटे सिस्टम जो सिस्टम रे रही कि आमे टोटल ऑब्जर्व करि परिबा. ताले जेमति ये ग्राउंड सिस्टम रे रही कि ए जन को ऑब्जर्व कला से ऊपर को ऊपर जाउछन, दे आर मूविंग विथ अपवर्ड डायरेक्शन. बट तो आमे लिफ्ट फ्रेम को पळे जिबा, तमे लिफ्ट फ्रेम रे देखिबा ताले ये को कंडीशन रे अछि, रेस्ट कंडीशन रे अछि. सो मोशंस एंड रेस्ट एंड मोशंस आर रिलेटिव टर्म, and the relative motion which depends on this frame of reference. So frame of reference hela important. Clear? Okay. Next, this frame of reference which is divided by 3 parts. First one, that is known as Cartesian frame of reference, and second one, that is cylindrical frame of reference, and third one, spherical polar frame of reference. But here we only discuss about Cartesian frame of reference. Clear? So this cylindrical frame of reference and spherical polar coordinate system or frame of reference you will study your higher study level, but here we will discuss only about what is Cartesian frame of reference. So Cartesian frame of reference mean in 3-dimensional system, Cartesian frame of reference, and in this case we will study the frame of reference which consists with x, y, z axis. Clear? And that is known as Cartesian frame of reference. Suppose there is one axis, x axis, and another one axis which is perpendicular to this x axis, that is known as y axis, and third axis also perpendicular to both x and y, and this is the direction of third axis. Clear? And I am writing here this axis is z axis, x, y, z axis is here. Clear? So this point we can say this point is O, and when we observe x axis, y axis and z axis, at that time we can say this system is known as Cartesian coordinate system or Cartesian frame of reference. Cartesian frame of reference पाई आम x coordinate, y coordinate और z axis consider करिबा. But the range of x, y and z, its range which this is origin, and origin means we have to choose here 0, 0, 0 its coordinate. This is known as coordinate. Here x0, y0 and z also 0. So coordinate of origin 0, 0, 0. So the range of x, here 0, we can take it to plus infinite. If this point 0, then x must be starting from this here, that is minus infinite. So the range of x which is minus infinite to plus infinite, and again range of y, that is plus infinite, here minus infinite to also minus infinite to plus infinite. Clear? And next the range of z also here minus infinite to plus infinite. This is Cartesian coordinate system, and this Cartesian coordinate system which is divided by again two parts. So what are Cartesian coordinate system? In this case we will discuss two type of frame of reference. First one, that is inertial frame of reference, and second one, that is non-inertial frame of reference. So what is inertial and what is non-inertial frame of reference? So in case of inertial frame of reference, when a system or object, when a system moving with uniform velocity, clear? At that time the frame of reference is known as inertial frame of reference. Means system moving with uniform velocity or constant velocity. Clear? If a system is moving with uniform velocity, then we will discuss later what is acceleration. Actually acceleration A equal to V2 minus V1 by T2 minus T1. Change in velocity divided by change in time here. So change in velocity, but here uniform velocity. So uniform velocity means change in velocity equal to 0. There is no change in velocity for uniform motion which divided by time equal to 0. So for inertial frame of reference, a system which is moving with uniform velocity with acceleration equal to 0. This is second important point, where acceleration of the system will be 0. Means suppose there is a lift, and this lift which moving upward direction with speed 2 meter per second. After some time it reaches this point, and again this speed how much? That is 2 meter per second. Again after some interval of time this is also moving 2 meter per second. This is known as inertial frame. Why? Because here the lift means system which moving with a constant velocity, and where acceleration equal to 0. Clear? ताले inertial frame क्या कुआ जाए? Velocity टा constant है थीवा और uniform motion है थीवा और acceleration टा 0 है थीवा. Clear? We already know what is Newton's first law, Newton's second law, Newton's third law. Newton's first law of motion means on the body which moving with some velocity remain on the state of initial state unless an external force acting on it. Means आमे जेपर्यंत एक्सटर्नल फोर्स अप्लाई करना है से पर्यंत कौन चलती हो गोटे बॉडी कंडीशन चलती हो. मीन्स देयर इज नो एक्सटर्नल फोर्स. इफ F इक्वल टू 0 देन मास इनटू एक्सेलरेशन इक्वल टू 0, देन एक्सेलरेशन इक्वल टू 0. मीन्स एक्सेलरेशन इक्वल टू 0. सो इन इनर्शियल फ्रेम ऑफ रेफरेंस न्यूटन्स फर्स्ट लॉ ऑफ मोशन इज वैलिड. Clear? Next come to non-inertial frame. When a system moving with non-uniform velocity means acceleration does not equal to 0. Acceleration can be 0 hoba nahi. This is the condition for non-inertial frame of reference, where Newton's first law of motion is not valid. एटी न्यूटन्स फर्स्ट लॉ ऑफ मोशन वैलिड हबा नहीं. कौन भाई? एक्सेलरेशन डज नॉट इक्वल टू 0 मीन्स F डज नॉट इक्वल टू 0. फोर्स केबे भी 0 हबनी. यदि फोर्स पड़िला से न्यूटन्स फर्स्ट लॉ न. Clear? So these are the difference between inertial and non-inertial frame. Means there is a lift which moving upward direction. Initially suppose there is 2 meter per second. After certain interval of time this lift also moving upward, but its velocity 4 meter per second. Suppose after certain interval of time this lift moving upward, but this is 3 meter per second. Then each instant of time its velocity changing. means this is the condition of non-uniform motion or non-uniform velocity. Clear? And that type of frame of reference is known as non-inertial frame of reference. Clear? So next we will start types of motion. Types of motion. There are different type of motion. So first we will discuss here, that is rectilinear motion. Rectilinear motion, and this is the type of motion when a particle, here particle, when a particle moving in a straight line path, and that type of motion is known as rectilinear motion, means only one coordinate change. Suppose there is two coordinate here, x axis and here y axis. Suppose one particle which moving along this direction, means only one coordinate change, here this direction, and this is known as rectilinear motion. And in rectilinear motion you have to know here only one particle, one single particle which is moving. But while we are discussing about translational motion, but in this case a body is moving from one place to another place. What is the difference between body and what is particle? Body means it consists number of particle, and particle means only one particle. Clear? So suppose there is a body here, and this body which constitute number of particles. Suppose there is particle number 1, here particle number 2, and this is particle, third particle, and here 4 particle. Clear? And now suppose I am writing here particle 2, particle 1, here particle 2. Now this distance, and suppose the distance is 1 meter or 1 centimeter. The distance between two particle 1 and here 2. So this object or this body which consists of two particle which form a body, means if a system or if a body consists number of particle, but particle means only one particle. So this is position number A, and if you displace this body to position B, another one position here B, but in this case this is one particle is here and second particle also is here, and again the distance between two particle, that is 1 centimeter, and this distance is known as interatomic distance. When a body displaces from position of A to position B, at that time the interatomic distance between 2 points or interatomic distance between the particle never change. That type of motion is known as translational motion. Or you can say the particle which are moving parallel to each other, because this one particle moving this direction, this point to this point, and again this two particle also moving this point to this point. Or you can say suppose here body moving this like this direction, this is point to 1 and here particle 2, and again this distance 1 centimeter, but here like this, and again here like this direction. Clear? So these particles are moving parallel, these particles are moving parallel to each other, and their interatomic distance or space between two particles never change. That type of motion is known as translational motion. Clear? But here one position change or one position to it changes another one position, means when a bus moving from one place to another place, that type of motion is known as translational motion. And what is particle? So what is rectilinear motion? When a particle moving in a straight line path, that type of motion is known as rectilinear motion. Clear? So next come to what is circular motion. Circular motion. Circular motion means when a particle which moving in a circular path and the distance from a fixed point always fixed, means suppose here a particle moving this direction and this is suppose this point is fixed point and this distance suppose r, and again this particle moving in this direction and this point is fixed and this distance is r, and again moving this direction and this point is fixed and this distance r. Clear? And which make a circular path like this. When a particle moving this path and which moving is a fixed distance from a fixed point, this point is fixed, and that type of motion is known as circular motion. Clear? So this is just basic idea about circular motion. In circular motion, each point radius always fixed and particle which moving in circular case. Clear? Okay. So next we'll come to that point, that is rotational motion. Rotational motion. So what is rotational motion? Actually, in case of rotational motion, first we have to know about what is rigid body. Rigid body means if we apply external force, then the interatomic distance or interatomic space between two particles never change. Means suppose I am taking here a body and there is two particles 1 and 2, and this is interatomic distance suppose here 1 centimeter. If we apply force this direction, and again this direction, then the final condition of this body like this, and again this distance 1 centimeter, means number of forces acting on a body but its interatomic distance 1 centimeter which is never changed. That type of body is known as rigid body. Clear? Okay. So in rotational motion we will discuss about, or we will discuss by taking rigid body. So in rotational motion, in this case a body, suppose this is one body and it consists number of particle, means rigid body. So particle 1, 2 and 3 particle. This total body which moving about a straight line, and that straight line is known as axis of rotation. Axis of rotation means about which this total body or rigid body rotating, means suppose there this is axis and about this total body which is rotating like this. Clear? This is known as rotational motion. And here in this case you can say suppose here particle number 2 here and here particle number 3, and this is known as axis of rotation, and particle 1 which is situated at r1 distance, and here this angle is 90 degree you can say, and suppose this particle 2 and this distance r2, and here particle number 3 which is r3. But in circular motion, here only one particle moving this direction with a fixed point. But in rotational motion, this particle 1, if total body rotating about this axis or axis of rotation, then particle 1 also moving this direction, means like this. So this particle 1 which make a circular path like this with radius r1. Similarly, there is another one particle 2 which make a circular path like this with smaller radius r2. Third particle which moving with a large circular path because its radius r. Clear? This is known as rotational motion, means each particle inside the body, each particle inside the rigid body which making a circular motion, means total body which rotate about a axis, but particles are making circular motion with different radius. that type of motion is known as rotational motion. Clear? So you can say this circular motion is one of the application of this rotational motion. Circular motion means only one particle which rotate about a circle, but here number of particles which making circular path about a fixed axis, and that axis is known as axis of rotation. Clear? So next come to what is vibrational motion. Vibrational motion. In vibrational motion or oscillatory motion, here we will discuss that is the motion which consists of to and fro. To and fro motion about a mean position. That type of motion is known as vibrational motion. Suppose there is a string and this string which is fixed this point. Clear? Now this string is stretch condition like this, and this is known as mean position. If we pluck the string, then suppose like this. बर्तमान स्ट्रिंग को प्लग करके शेप चेंज कर देली, बर्तमान स्ट्रिंग ए टाइप रही गला, एबे छाड़ देबी, छाड़ला पर ये अप डाउन ऑसिलेशन हबो लाइक दिस, एंड ऑसिलेशन हला गला एमती आस मींस इफ वी प्लग द स्ट्रिंग देन स्ट्रिंग वाइब्रेट दिस वे मींस, एंड दिस पोजीशन इज नोन एज mean position. Mean position means this is not initial position where net force acting on the body is zero. ताले ए पोजीशन अबाउट रे बॉडी अपवर्ड डायरेक्शन गला, पुनी मीन पोजीशन को आसिला, पुनी डाउनवर्ड डायरेक्शन आसिला, पुनी मीन पोजीशन गला. That type of motion is known as to and fro motion. Or we can say suppose there is a pendulum of length L, and at this point this pendulum is fixed and net force acting on this point is zero, and F net takete F net equal to 0, and that position is known as mean position. If you displace the pendulum from its mean position like this at an angle theta, ago theta angle में displace कर देले A point रो बता release करिवा, and that point is known as extreme position. एबे से गला and again come to another one position where velocity equal to 0. बर्तमान ए पॉइंट गला velocity 0 means this point also known as extreme position. We'll discuss clearly in SHM chapter, simple harmonic motion. Then it come to the final point or point B and again return to its original position. Means जब पार्टिकल को मीन पोजीशन रो ऑसिलेशन कले ताले ए फर्स्ट एक्सट्रीम पोजीशन को गला, पुनी अगेन मीन पोजीशन को आसिला, मींस दिस मोशन इज नॉट टू एंड फ्रो. टू मींस टुवर्ड्स ए पॉइंट को आसिला, फ्रॉम ए पॉइंट रो पुनी चलची, मींस टू एंड फ्रो मींस फ्रॉम, टू मींस टुवर्ड्स ए, फ्रॉम मींस फ्रॉम ए. सो टू एंड फ्रो मोशन अबाउट मींस ए अबाउट रे फास्ट गला पुनी आसिला. That type of motion is known as vibrational motion. We can say this is known vibrational motion, and this is known as oscillatory motion. Oscillatory motion. Clear? So these are types of motion, and another one type of motion here, that is known as one dimensional motion, and two dimensional motion, and next one three dimensional motion. So in one dimensional motion here only one coordinate change. When particle moving this direction, only one coordinate change, only x coordinate change. Suppose when time t equal to 0, the particle which is this, suppose this is origin and 2 meter distance from origin. After 1 second this particle which is at 4 meter distance, then here only one coordinate change, only x coordinate change, y coordinate never change. That type of motion is known as one dimensional motion. Clear? Motion of a, suppose you can take motion of a train, motion of a Train like this means straight line motion. Clear? Only one coordinate change. But in two-dimensional motion, two coordinates are simultaneously changed. X भी change हो चलथिबो, Y भी change हो चलथिबो. Means like this. So here, when particle this point x coordinate and here y coordinate, this point, when this point means x axis, from this is y axis, this point x coordinate and y coordinate, that type of motion is known as two dimensional motion. Or you can take example, that is circular motion. Circular motion, why? Because here two coordinates are changing. Here x change and y change, x change, y change, x change, y change. Clear? That type of motion is known as two-dimensional motion. Or you can say like this, this is known as projectile motion. Circular motion and this is projectile. We'll discuss in upcoming class. This is projectile motion, means x coordinate change and y coordinate also change. Clear? And last one, that is three-dimensional motion. So here three coordinates are simultaneously changed, x axis, y axis and another z axis. Means motion in space. Motion in space are the example of three-dimensional motion. Means three coordinates are simultaneously changed while motion. X axis change haba, y axis change haba, z axis change haba simultaneously. That type of motion is known as three-dimensional motion. Motion of flying bird means motion of aeroplane, you can say like three-dimensional motion. Clear? Two-dimensional माने दुईटा कोऑर्डिनेट simultaneously change हबा. One dimensional means only one coordinate change हबा. Three dimensional means तीनटा को coordinate change है चलिबो. Clear? That type of motion is known as 1D, 2D and 3D. Clear? So these are all about types of motion and what is rest, what is motion, what is inner shell frame, what is non-inner shell frame. Clear? So next we will start motions parameter. Thank you all.